automatically send it as an email yet. So I don't know. That might be tough.
They should feel this guy.
It may be easier to just send him a link to the box location that has the text file than it is to send him, because from a Python script that will have to somehow plug into the Outlook/Exchange system of the company.
Oh, I'm sure there's a Python package for mail.
There probably is, but I don't know how we handle password stuff. Because I would, like, if it's on my laptop running, I can keep my password on my laptop, that's fine. But if I have to put it on a server, the script on a server, and then the script has to obtain the password, my password in order to send email. You know what I mean?
Yeah.
Machine learning expert.
I'll look into that.
I mean, he was kind of cool.
We've dealt with that a lot. We have
stuff that was like related to it. So
we have basically like an encrypt decrypt function that's specific to the server. And so like essentially no one else. Yeah.
Sort of ill-defined.
I don't know the fine details of it. My coworker is the one who set it up, but basically we have a script on our Linux server that's just encrypt whatever, and then you just leave it there.
This year is much more kind of like.
It might also be the case that other people have already set up some dummy user anyway for this kind of things, and maybe I can get that password.
Outside of here.
How do you guys? If you guys have like an API key for some external service or something like that, how do you guys manage that? Because my problem is, like, I was doing Twitter stuff, when I signed up with it with my personal email a while ago, like, I just used my old one that I used like 3 years ago for a project, and it's like, well, we can't really use this. Not that it costs anything, but it's just like, if I leave, then no one else can use it, or like whatever.
Yeah.
But we don't, like, do you guys have like a separate email that's just like, this is like full company stuff?
Not fake, but like a generic email.
I mean, you could just create a Gmail one if you really wanted to, right?
Okay.
Yeah.
Even though it's being used on behalf of the
I mean, we
company.
have like a corporate
Cool.
Gmail, G Suite.
Oh, okay.
Oh, I'm the IT.
You're the IT?
I don't want to be, but you know. So I create like a generic account, and then I set that account to do some of the common tasks.
Yeah. And I put certain things that I don't want to make, like I've pushed some things up on GitHub. So I just put, I think it was my API key, I put in a separate file in a dictionary, and I input, and in the code I input the dictionary and I retrieve the key. But I never submitted the dictionary file which you probably have done 1,000 times.
Well, that's similar to what my ideas have been. Typically, I've been too lazy to actually like kind of branch the two. But
I mean, once I put it in a dictionary file, I then just put it in the git ignore, and then
I'm just really bad at Git. So like,
so am I.
Even with like Git ignore stuff, I'm like, that seems like too much work.
All of this looks like too much work.
I don't know. I've heard
I watched the video. No, I watched the video yesterday. It was this guy explaining how to filter in pandas, how to filter entire rows in and other rows out through the value of one column. And it was like a 15-minute video. He probably could have done it in just 2 minutes. But what I liked about it is that he started from, like, instead of giving you the final answer and then deconstructing it, he started from the bottom up. He said, we want a list of true and false based upon which rows we want to keep in. Then he turned that list into a series, panda series, and then he put the panda series into the data frame, and he got the result. And then he showed how to do this in a much 15 minutes, but I actually have no regrets watching it because I kind of figured out the whole thing. This guy's called Data School. Hey!
Ilya's back.
I haven't seen this guy since before he had a beard.
Oh my gosh!
Yes. We can probably spend a lot of time doing data, right? Like you're usable or is it unusable?
It just depends on what context it is.
Okay.
We're gonna move. We're just here, you know.
How did you know about the project?
Pull it up.
So, but some of the other projects there is, I don't know about this PetFinder one.
Aren't you done with your project?
What project?
The submission?
But yeah, but there's
Oh no, we gotta do that today.
clean up your day.
Isn't the submission deadline last week?
No,
This Tuesday.
Oh.
don't scare me like that. Like, no.
It was maybe the day to
No.
sign up.
Long pause.
I got an email.
That was the team merger deadline. So that was when you had to have your team formed.
Put together.
Yeah. And so it ends on Tuesday, Wednesday, something like that. But then they have to actually rerun all of the kernels on the new data. So they're saying that it's going to take another 3 weeks or something like that. So that's going to be a period of suspense.
Of not knowing.
Yeah.
Nail biter. We were just talking about Siraj. We should spend time watching Siraj
Yeah.
videos.
So,
Oh, can we just
Watch that.
watch the one?
We could, yeah.
is this?
Not trying to hate on him. I'm not
You don't
the
like him?
biggest fan of
Oh, I
his,
love him.
but
Is he one of those YouTube guys?
Yeah.
he's super high energy,
I
and he
know
just
that.
throws all the concepts at you, and he's just like, oh yeah, and then you just install TensorFlow and you do this thing, and then it's done. And
Just install
Yeah.
TensorFlow.
He's the
Just
PR
install
guy. He's not
Python.
the engineer.
We joke because my boss always uses the word just. Can't you guys just do blah blah blah? Can't you just?
Yeah.
I'm like, no.
Hello,
you
world.
can't Just.
oh god,
Yeah.
Oh yeah, this guy, Siraj.
Oh, you're not gonna play the data lit one?
the what?
I think
Oh,
that
No,
might be
no,
a
no,
bit
I-
No,
much.
no.
I was joking.
Yeah, I understand now. So background on this video. He's talking about Kaggle Days, which is this event that they just put on in Paris, which was kind of this just big jumbo version of what we do. That was multiple day event, and they had some hackathons and they had some speakers and they had all kinds of stuff. And so this is Siraj with there, and he is covering this topic.
It's Siraj, and I'm here in Paris at the beautiful Station F co-working space for Kaggle Days. Over 200 data scientists have flown in from all over the world to attend data science talks, socialize, and compete in a data science challenge. Kaggle is a platform for data scientists where they can participate in competitions to solve problems for companies using their data sets and win prizes. Kaggle holds these events a few times a year, and the event lasts up to 3 days. In this video, I'm going to show you some footage of the event, then conduct a Q&A with 5 talented data scientists, including the CEO of Kaggle, Anthony Goldblum, and lastly, I'll demo a data visualization tool that one of the participants will be using in the competition. Ready? Let's make the data lit.
Are we gonna watch the whole thing? We're gonna watch the whole thing.
It's 10 minutes. We can if you want.
Can you put it on like 1.5x?
With Siraj, that's going to be.
It's too much.
I know, I've seen that. They give
Yeah,
you
my
some
name is
materials
Daniel.
and stuff. And
I'm from Israel.
could be
I'm
interesting. I
producer
haven't
for
looked
Get,
into it too deeply.
GetXC.
Jorge Ariano. I'm from San Diego, California, born and raised. I am currently a researcher at San Diego State University.
My name is Turdahia Bawelena. I'm from Russia originally, but now I live in France. And I'm data scientist at Enabloom.
So I'm Karthik. I am a data scientist. I'm from India. I'm working in Berlin at Poster Digital Lab.
Anthony Goldblum. I'm the CEO of Kaggle. I'm originally from Melbourne, Australia, but I now live in San Francisco.
I started as a software engineer and got to know the whole field of machine learning something like 4 or 5 years ago. Did the Andrew machine learning course. Started to compete in Kaggle.
I had seen a video about deep learning and how they could instantly price every single apartment. I was currently in real estate, and I realized that my job was going to end if I didn't do something. And as a survival tactic, I pushed myself to learn how to program.
In the childhood, so when I choose mathematics as my favorite subject, and I continue developing my knowledges in mathematics and physics, then I started to work as a data scientist. And but besides, I also wanted to try to participate in data science competition.
I was doing my postdoc, and then normally the postdocs are short term. I have contracts like 1 or 2 years. So I wanted to look for a more stable job, and since I had a background in programming and data analysis, I thought maybe data science is a good option.
So I was a statistician or an econometrician by training. I came from a statistics background, but was a hobbyist programmer and started playing with more of the machine learning techniques. After they started clearly doing well on Kaggle.
I love programming to start with because it lets you to create something from nothing. And data science is even take it one step further because you can change the world.
Because it's hard. And if it's easy, I'm not interested.
You always have a new, something new. Besides the fact that you are able to learn algorithms, you're also able to learn some industries because data are coming from different industries.
Doing the data processing and trying to understand, gain some valuable insights.
You get a raw data set, right? And it has all these secrets kind of hidden in it. And it's like, you almost feel like a digital detective, right? You've got this data set and you want to uncover its secrets.
You finally get to meet the people behind the kernels and behind the code.
Wonderful. You can get a bunch of nerds in one place and talk stuff that is interesting to us.
Oh, it's perfect. So actually, it's my first experience in Kaggle Days, my first edition. And so far, we have seen 2 presentations. It was very useful and very well prepared. And really, I think everyone could take something from them.
Oh, Kaggle Days is really an interesting event. I was there also in the first edition. And after the first edition, I thought, oh, I shouldn't miss the second edition. It was really informative, and it's a good place to meet top Kagglers.
You know, it's amazing to come to an event like this, speak to so many people whose lives we have touched, and that's an amazing thing, right?
Generating art with machine learning, generate music, generate pictures. I think it's the most exciting thing.
Natural language processing. The fact that we're able to communicate with each other and not kill each other daily is probably the most impressive thing.
I would say competitions.
Mostly I'm mainly focused on sound-based anomaly detection. I would also try to move more into reinforcement learning.
I think I like the combination of where there's a physical reality behind the data set. Love weather data. Love data where there's sort of the physical world meets where data meets the physical world. Those are the problems I find most interesting.
First of all, they need to love it. Once they love it, it doesn't matter how they learn. I think Kaggle is a good infrastructure. I think it's the best.
Kaggle Learn. Kaggle kernels too. And Siraj Revolve, for sure.
I would say it's Coursera and it's Kaggle.
Mainly, it's the YouTube videos, online tutorials on Medium.
Well, I'm going to give you a biased answer here, but it's Kaggle. And of course, your videos. Those are 2 of the resources that I think are exciting. And then once you've learned the basics, jump into a competition, play with a data set on Kaggle. Don't just watch videos or read tutorials. Use the stuff that you learn.
Usually things don't go well as you expected. You try something and it doesn't work, and you think, oh, maybe I didn't understand the things as I think I did. But then it's a lot of failures until you manage to do something right.
Nothing works for a really long time. That's the craziest thing. And the fact that you're pushing yourself to get a 1 or 2% increase in accuracy, that's probably the hardest part.
You always don't have enough time to spend. And another thing, it's developing too fast. So it's really difficult to keep yourself being updated.
If I have to look into some specific problem, for example, I don't know, the wavenet or a new alpha goes 0, if I have to understand the paper, if I have to try to understand what is written in the paper and try to implement, that's one of the hardest things.
Asking a question that is meaningful and where the results are actionable. We're getting to the point where there are a decent number of people who are good at using the tools and technologies to pull answers out of data. where I think companies often struggle is not having a good intuition for what sort of what sort of questions can get asked. I think that's what's rate limiting us.
To be a data scientist for a project that I really think will change the world.
Apple or Google?
I would say research data scientist.
I would like to stay in data science. I mean, I absolutely love it.
I like my job. I'm proud of the impact we're having, and I think it's a small fraction of the impact that I hope we can have over the coming years.
Don't be afraid to fail.
If it gets really hard and nothing is working for you, you're just around the corner to success.
Try new things, communicate with others, learn from others.
Attend as much online courses that you can attend, and then learn from it. Of course, YouTube videos are really good.
I think it's important to be tenacious, and I don't think this is just for data scientists, right? Maybe you come to Kaggle and you're intimidated, and you think, oh, I can never perform at the level that some of the top people are performing at. And I think it's really important. First of all, just get a model into a competition. Doesn't matter how bad it is, and then come back day after day after day and just try and make small improvements. You might find that for a week you're not really making meaningful improvements, but continue to have tenacity, because one day you will make a breakthrough, right? And it's going to be incredibly rewarding, and you're going to continually level up. But it's very important when you do hit plateaus to push through them.
Hey, Ethan, how's it going?
Hi, Suraj. I'm doing very well. How are you?
I'm pretty good. Can you show me what you're working on?
Sure. So what we're doing at the moment is to look at a prediction problem for a customer who produce perishable goods. They basically provide a bakery product like croissant and bread. So in the current situation, they send human beings inside a store to estimate how much a certain product might require. The particular problem for this kind of client is if you buy in too much stock, some of them might go bad. So what it turns out at the moment is by using XGBoost to generate a machine learning prediction, the model tend to be more conservative compared to the human being. So in that sense, it's good for the client to have a more conservative estimation because you don't waste so much product. It's also good for environment as well. So by working out each product line, saving the loss by aggregating to a store and then to a nationwide for this particular bakery chain, we work out they can save something like $2.5 million per week.
That's a lot.
Yes, it's amazing. Go check it out. Yes.
Cool. Thanks so much, Ethan.
No problem. It's my pleasure.
Please subscribe for more programming videos, and for now, I've got to find an anomaly.
So yeah, that's the video. The guy at the end there, I've actually talked to him a little bit before, and some of the people who were talking at Kaggle Days, I've interacted with them a little bit. So I know some of the people who were over there and some of the people who went, and they said it was really cool. So someday we'll have to figure out how to get a San Diego-based event or go to Paris. That works too. It's a lot of people now.
Yeah. So what's on the agenda?
Yeah. All right. So I have been updating our Trello board. And so this is a ticket just kind of to remind myself to talk about the stuff that we covered last week. And so last week we talked about the different information that was given to us in the competition. So what variables are we looking at? And they're telling us stuff like what city was the pet in, what breed was the pet, and stuff like that. And also we looked at what we're trying to predict. We looked at numerical and categorical variables. We'll dive in more to the categoricals today. We looked at some exploratory data analysis, seeing some trends in the data, and just looked at some graphs basically. And then at the end, we made a simple decision tree model, and we also showed the output of the of the decision tree, and we looked at it visually. You've got that up. Do you want to swap over? Perfect. So this is what we worked on last week. We basically figured out what fields of the data can we look at that are already numerical, and we could just throw them into our decision tree algorithm.
Oh yeah, we did that in the list. Somewhere we had a list of.
Go down a little bit.
Was it this? Was it? No, it wasn't this.
No. List of num fields.
Yeah.
So those were basically the fields that we could pull out, and these are already numbers that we can just easily plug into the algorithm. And then this week we'll be dealing with categoricals, and then in later weeks we'll be dealing with some of the other types like the text and the images and stuff like that. And so what ended up happening is we train a decision tree, and then we can look at what the decision tree looks like. And so we found that the decision tree it's looking at age less than or equal to 3.5 is months, and then it's splitting off and making decisions from there. So if that condition is true, then it's probably class 2, meaning that it's going to take less time for the pet to get adopted than a class 4. And that kind of makes sense, because if it's less than 3.5 months, that means it's like a puppy, which is probably highly attractive when you're looking at adoptions. And so that's pretty much what we worked through last week. For you guys still working on the Quora, if you want to break off now, that's probably a reasonable time to do that.
Hey, I was just curious. When I went to the bottom of this, did you find this kind of useful? Is this public?
No, not yet. It's just always there, even if it's private, just for yourself.
So how would I make it public if I wanted to?
If you want to make it public, you go over to this Access tab, and then you would change it to public. Yeah.
Okay.
Yeah.
I saw that lock over there. I was like, oh, I won't be able to go through that. Hi, I'm Leo.
Ryan.
Ryan, nice to meet you.
Yeah. Do we have enough room at the table now? With them out of the way?
Is this taken? No.
No, go for it.
You don't mind me asking?
Yeah.
So my chair asked me to meet a gentleman here named Shane. I don't know if
Shane emailed me earlier, and he said that he couldn't make it. Yeah.
Okay.
So if you're intending to meet him, he's not going to be here.
Okay, I'll let Vish know too.
Okay.
All right.
Yeah.
You don't mind if I just kind of watch for a bit?
No, that's cool. Yeah.
Okay.
For sure.
Want to see you?
So last week we trained our model, and then some of us made predictions, but we didn't have any way of necessarily knowing how it performed unless we actually submitted to the leaderboard. And so what we'll talk about today, is figuring out how we can do local validation of our results. So understanding with the stuff that's actually labeled and public to us, so we can see what we're getting right and what we're getting wrong. And so there's several different methods for us to use to do that. The simplest, the one that I'll start with, is the train test split. So imagine we've got, let's just say this is all of our questions, and then we do a train test split. This would be taking our train set, which is, I think, 16,000 pets. I'm not sure the exact amount, but about 16,000. and then let's say we just set aside 20% or something like that. And so what we're planning on doing with this, basically, is we've got 80% of the data that's labeled, right? And we will learn from this 80%, and then we will use this last 20% as like a grading set. So it's sort of like if you're ever taking, like if you're in a math book or something like that, you start by learning from the problems, and you've got the section with the answers are right there, and you're kind of just working along with it. And then you've got the additional problems where it's 5 questions or something like that, and you do it, and then you don't know the answer until you flip to the back of the book and you check and you say, okay, I got these 5 right, or I got 4 out of 5 or something like that. That's the basic gist of the train test split, is you can't necessarily gauge your accuracy based off of something that you've already seen, because your algorithm is obviously going to be able to match whatever it's looking at. So you need to look at untrained on data in order to figure out what your accuracy is going to be. And so train test split is probably what we'll start off with in the kernel that we've been working on. But beyond that is k-folds. And so the way k-folds works is, instead of doing one split, we split the data 5 times, so each of these are 20%. And then what we'll do is we'll train one model using these 4 segments of data, and then grade ourselves on that. And then we'll also do k-folds. So k-folds, k is some integer number, so you can do 2 folds, 3 folds, 4 folds, 5 folds. And that's how many times you're splitting the data up into equal sized parts. And then from there, you're training k number of models. So you're looking at subsets of the data and then holding out one of them, and then using that for measuring your metric. And so what you're essentially doing, if you basically unwrap it, you'll do these 4, then let's say these 4, actually erase that. So we'll use this as the holdout for 1, and then this is the holdout for 2, and then 3, and then 4, and then 5. And so you're using each different chunk as a holdout at a different time. And then since you've trained on all of the different data 5 times, you're able to also grade yourself on the 5 opposite chunks. And so you're able to grade yourself on unseen data on the entire training set, instead of being limited to just 20%. So you have a metric that's valid for the entire 100% of the data. And so the way that I look at this is like kind of the same school book analogy. Is, let's say that you have 5 friends and you tell each of them to look at 80% of the material and not look at the other 20%, but you all still take the test, and then you aggregate all of the stuff that you guys were missing, and then you figure out, add it up, how good your training was, basically. So you're aggregating across all of that stuff. And so this is really good for, instead of training a model once, you're training a model 5 times. So if you have a lot of data, then it's kind of redundant, and you have to spend a whole bunch of compute on training 5 times as many models. Does that make sense so far?
Good.
And then, so last week we looked at the numerical variables for the most part, but we kind of just skimmed over the categorical variables. We just set those aside for now. So now we will dive into how to actually handle the categoricals. So one example of categoricals in our data that we're currently looking at is the city. So like, is it New York? Is it LA? Is it whatever? So there's all of these different categories of cities that we could potentially have, but the problem is we need some way to represent that numerically. And so one way of doing that is we could just go really simple and we could say 1, 2, 3, 4, and so on. But the problem is when we put this into our models, this is showing us that potentially whatever is number 1 is more similar to LA than something down here, when that's not necessarily the case. They're kind of unrelated for the most part. You wouldn't say that New York is more similar to LA than LA is to Virginia or something like that. So we need some way in order to show that they are entirely distinct so that they aren't similar in any way. And there's not this kind of information that's inadvertently passed by just turning them into IDs. And so the that first method of turning them into IDs, that's something that you can find in the scikit-learn label encoder. So if that's something that you want to do, you can just use the label encoder and it will find all of the different labels for you. And so let me pull this up. And so like with this example, you can see that they've got this list of cities. So it's Paris, Tokyo, Amsterdam. And then once you fit on that, it learns, okay, so the different IDs that we're looking for are Amsterdam, Paris, and Tokyo. And then when you look at future data, it can go, okay, Tokyo was the second index, so I'm going to turn that into 2, 2, and then Paris was the first one. And so that's a simple way you can do that without writing any more complex code. You just take it straight out of scikit-learn.
So I mean, it's just counting the different states. The unique values of whatever we're, okay.
Yeah. So it just assigns an ID to each unique city, basically. And so the alternate to this is one-hot encoding. So instead of representing it as single integer values, you can represent it as a list. So let's just keep it simple and say we only have 3 cities. And so if we're trying to represent the city of New York, then what we could do, this is why it's called one-hot encoding, is we do a 1 there, and then we do 0, 0. So we're saying it is New York, it's not LA, and it's not San Diego. And so if we wanted to do LA, we would do 0, 1, 0, and if we wanted to do San Diego, we would do 0, 0, 1. And so that's a simple way of representing them, and it's such the case that these are all equally different, basically. If you plot it out that, I'm going to totally butcher this because I'm trying to do in 3D. But basically, so imagine this in 3 dimensions. So let's say you're going here on the x-axis, you're going here on z, and you're going here on y. These are all actually equidistant apart. So this is the same distance to that, is the same distance to that. And so you can tell that they're all equally dissimilar. And so that's one valid way of representing categorical information, is just basically saying they're all totally dissimilar, just put them in different dimensions. So they're all equidistant apart. But the problem with this is that they're not necessarily entirely unrelated, right? There's probably some connection between major cities or places that have preferences for cats or something like that. And so the concept of embeddings, the next thing that we'll be talking about, is basically let's start in this three-dimensional space, four-dimensional space, whatever, and then let's move points around so that ones with similar results end up in similar spaces. So let's say that this is New York, and this is LA, and this is San Diego. Well, let's say that New York and LA are more similar actually than San Diego because they're larger cities. So what you might do is you move this point towards that, and now they're marked as more similar. And so the way you do that is essentially you take these numbers and you adjust them until they're closer to what the similarities represent. And so each unique city will have its own embedding, which is essentially its spot in whatever dimensional space. Three-dimensional space can be 300, but we just can't draw it and visualize it. And so embeddings are pretty complex, and I can't go into full detail on them, but there's a bunch of good material on there. And if you're using Keras or something like that, it pretty much handles it out of the box for you. You don't have to do any complex math or anything. And then the last one that we'll talk about is target encoding. This one I haven't had much success with in competitions, but I think it's kind of a nice, satisfying idea. So the first time that I encountered this actually was in a competition where we were trying to predict the price of items on a marketplace. And it kind of, the way that target encoding works is you look at basically the target that you're looking for, and then you use the mean of that for that category. So like if we're using, if we're trying to predict price on a marketplace like that, then we know that we're in the category of shoes. And then we find the average price of shoes on the marketplace, and then we use that as a numerical input. And so that works out well because it gives us a direct signal of shoes are typically $60 or something like that, and then the rest of the network can find out, move this up because it's a nice shoe, or move it down because it's a cheap shoe or something like that. And so that's kind of the idea behind target encoding, is you take directly what you're trying to predict and you encode it into the category information, and then you pass that into the neural network. And so I originally found out about this from this Coursera video that we can take a second and watch. It's very Russian, just giving you guys a heads up.
Hi everyone. In this section, we'll cover a very powerful technique, mean encoding. It actually has a number of names. Some call it likelihood encoding, some target encoding. But in this course, we'll stick with plain mean encoding. The general idea of this technique is to add new variables based on some feature together with target. In simplest case, we encode each level of categorical variable with corresponding target mean. Let's take a look at the following example. Here we have some binary classification task, in which we have a categorical variable, some city. And of course, we want to numerically encode it. The most obvious way, and what people usually use, is label encoding. It's what we have in second column. Mean encoding is done differently, via encoding every city with corresponding mean target. For example, for Moscow, we have 5 rows with 3 zeros and 2 ones. So we encode it with 2 divided by 5, or 0.4. Similarly, we deal with the rest of cities. Pretty straightforward. What I've described here is a very high-level idea. There are a huge number of pitfalls one should overcome in actual competition. We won't dig into details for now, just keep it in mind. At first, Let me explain. Why does it even work? Imagine that our dataset is much bigger and contains hundreds of different cities. Let's try to compare, of course very abstractly, mean encoding with label encoding. We plot feature histograms for class 0 and class 1. In case of label encoding, we'll always get totally random picture, because there is no logical order. But when we use mean target to encode the feature, classes look way more separable. The plot looks kind of sorted. It turns out that this sorting quality of mean encoding is quite helpful. Remember, what is the most popular and effective way to solve machine learning problem? It's gradient boosting trees. XGBoost or LightGBM. One of their few downsides is an inability to handle high cardinality categorical variables. Trees have limited depth. With mean encoding, we can compensate it. We can reach better loss with shorter trees. Cross-validation logs might even look like this. In general, the more complicated and non-linear feature target dependency, the more effective is mean encoding. Okay, further in this section, you will learn how to construct mean encodings. There are actually a lot of ways. Also keep in mind that we use classification test only as an example. We can use that method on other tasks as well. The main idea remains the same. Despite the simplicity of the idea, you need to be very careful with validation. It's got to be impeccable. It's probably the most important part. Understanding the correct leakless validation is also a basis for stacking. The last, but not least, are extensions. There are countless possibilities to derive new features from target variable. Sometimes they produce significant improvements for your models. Let's start with some characteristics of datasets that indicate the usefulness of mean encoding. The presence of categorical variables with a lot of levels is already a good indicator, but we need to go a little deeper. Let's take a look at XGBoost's learning logs from Springleaf competition. I ran 3 models with different depths, 7, 9 and 11. Train logs are on the top plot, validation logs are on the bottom one. As you can see, with increasing the depth of trees, our training error becomes better and better, nearly perfect. And that's a normal part. But we don't actually overfit, and that's weird. Our validation score also increases. It's a sign that trees need a huge number of splits to extract information from some variables, and we can check it from model dump. It turns out that some features have a tremendous amount of split points, like 1200 or 1600. That's a lot. Our model tries to treat all those categories differently, and they are also very important for predicting the target. We can help our model via mean encodings. There is a number of ways to calculate encodings. The first one is the one we've been discussing so far, simply taking mean of target variable. Another popular option is to take a natural logarithm of this value. It's called weight of evidence. Or you can calculate only the number of ones, or the difference between number of ones and the number of zeros. All of these are viable options. Now let's actually construct the features. We will do it on Springleaf dataset. Suppose we've already separated the data for train and validation, XTR and XVal data frames. This code snippet shows how to construct mean encoding for an arbitrary column and map it into new data frames, train new and val new. We simply do group by on that column and use target as a measure. Resulting means variable is pandas series. It is then mapped to train and validation datasets via map operator. After we've repeated this process for every column, we can feed XGBoost model on this new data. But something's definitely not right. After several epochs, training AOC is nearly 1, while on validation, score saturates around 0.55, which is practically noise. It's a clear sign of terrible overfitting. I'll explain what happened in a few moments. Right now, I want to point out that at least we validated correctly. We separated train and validation, and used only train data to estimate mean encodings. If, for instance, we would have estimated mean encodings before train validation split, then we would not notice such an overfitting. Now let's figure out the reason of overfitting. With rare categories, it's pretty common to get results like in an example: target 0 in train and target 1 in validation. Mean encodings turns into a perfect feature for such categories. That's why we immediately get very good scores on train and fail hardly on validation. So far, we've grasped the concept of mean encodings and walked through some trivial examples. We obviously cannot use mean encodings like this in practice. We need to deal with overfitting first. We need some kind of regularization. And I will tell you about different regularization methods in the next video competition. I ran.
All right. So now I think what we should do, can you make that kernel public that you had up? So we'll branch off of the work that we did last week, and our goal now is to set up a validation setup. So either the train test split or k-folds, and I can walk us through those different options in sklearn. And then we can also spend a bit of time working on the handling of the categorical variables. And once you make that public, can you post it in Slack?
Yeah. What do I do other than that?
You can just take the link and just paste it in, I think. Yep, okay, we can see it then. So now everyone you can just go to that link and then click fork, and then it will pull up a new copy for you, and you can start playing around with that stuff.
Your screen is mine.
Yeah.
Maybe we're connected.
No.
We're gonna do a split, you said?
Yeah. So we'll do the train test split, and so if you guys are on the Trello board as well, I'll post a link for that again. Then all of the links in there are available as well to the various train test split k-folds and so on. So to show you guys how simple it is with sklearn, all you have to do is you import from sklearn.model_selection, import the train test split function, and then we have that, and then this is from last week. We load in all of the data, we look at what shape it is, and then we're able to just do train test split on the train data frame that we had, and then it will split it into two separate parts, so train df and val df.
Did you tell it the percentage?
No, I didn't. That's what I was about to fix. I realized I didn't put that in yet. And then we can do test size equals 0.2. And so what that's going to do is 80% will be used for train and 20% will be used for test. Let me start this from the top though. And so now if we look at train df, it started as about 15,000, but now it's only about 12,000. And if we look at the validation data frame, it's about 3,000. So those two together make up the entire set, but we split it into two parts. One of the parts is 80% and the other part is 20%. And so now we've got this decision tree classifier, and what it's doing is it's just looking at these 1, 2, 3, 4, 5, 6 variables, and it's learning from the training data frame. So the format of this is the x is the variables you're looking at, and then this second input is the y's. That's the thing that you're trying to fit to. That's what we're trying to predict. And so we will train on that. And then Leo originally had it so that he could make a prediction on the test data frame just to see what does it output. And so what we can do instead is we can plug in the validation data frame now and remove this. This was making it so we're looking at just one example. Now we can look at the entire validation data frame and all of its predictions, and so we can output that to a variable validation predictions, so val preds, and now we can actually look at it. So we print it off and we see that it's predicting summer 2, summer 4, and so on. And so our next step will be to see how it's actually doing. So the thing that we discussed last week was the metric that we're using is the quadratic weighted kappa. And hopefully I can find that in here. And so what people found in the forums is that this is the same as the Cohen kappa when you set the weights to quadratic. So that's what we'll import here. Need to make sure I'm doing this right. Yeah, okay. So what we did here is we imported the Cohen kappa score, and then what we did from here is we pass the predictions and the actual values to the function, and then we set the weights to be quadratic. And then it outputs the value, and we see that we got 0.234 on that local 20% that we're grading off of. And so now we can look at how to handle the categorical variables and see if that gives us any additional performance, and see if we can go up from 0.234 and get any additional information out of those categoricals.
Question.
Mm-hmm.
How do you choose the metrics? So out of all the metrics that are listed there, what's a way to figure out which metric to use?
The reason for this one is because that's what they're grading us on the competition.
Oh, okay.
So that's the major thing.
I see.
That's what they gave to us, yeah.
Okay.
And so now I think what we should do is split into some groups and try to do the various different ways of handling categoricals. So we've got 4 different methods. I'd say probably pause on the embeddings for now, because that's going to require Keras probably, and it's just going to be too much work. So I'd say let's stick to the label encoding, one-hot encoding, and target encoding for now. Does anyone have a particular interest in any of those?
I'll take target encoding.
Yeah. Okay. And so if anyone wants to work on target encoding with Tommy, talk with him, and then other than that, I guess you guys can figure it out.
What did you use from sklearn? What did you use to actually split them?
Train test split. I put a.
Oh, did you put it on the
I
slide?
put the link to the Trello, and the Trello has all of the different stuff that we've looked at so far. And so if you look at validation setups, I have links to K-folds, train test split, and so on.
So were you applying the targeting or the labeling to any specific like CSV file, or is it specifically the state one that we're doing for labeling, or others?
I'm not sure I understand your question.
Well,
what do you mean by that?
It would be any categorical attribute, right?
So we're
Yeah.
doing for all of them then? Okay.
Yeah, potentially. you can start with just one, and then you just figure out how to apply it to all of them. But
Okay.
yeah.
And the goal then would be to like put that into like one data frame from all the separate
Yeah.
data and then category. Okay.
Yeah. So if you look at the way that they had it set up on the in the video, they have a snippet of code that basically the first thing it does is it calculates the mean for each category, and then from there it will match those categories with the mean encoding and just replace that in place on the data frame.
Okay. Okay. Cool.
Did you say you used train test split?
You're trying to use that?
Yeah. Did you shuffle everything before?
No.
I just did a shuffle. But I'm having a hard time figuring out how to do the actual split. Did you use this kind of?
Let me see what you have.
I have two examples here, but I'm not sure I can follow them. So, input train test split.
Yeah. So, train test split. It's
function.
It's kind of magic in that it can handle pretty much anything you put in there, and it will understand what you're trying to do. So, if you have a data frame like this, you can just do train test split. Train df.
In parentheses, the function. Oops.
And then just do train df. And if you just ran that as is, see what it outputs. So it's already done the split for you. So that's all it needs. So it just used the default values of whatever the split amount is and all that stuff. So it output the validations that it looks like. It probably set it to like 75% train or something like that.
Okay.
And so now all you really need to do is set your test size or train size. You can set either to the fraction that you want. So you just do comma and then test size, I think it is. Let me double check. Yeah, so you could do test size equals 0.2 or something like that. And then
here you mean
no,
like I just define no.
And then so like with what I did train df comma val df.
Okay.
So the first variable is the train df and the second variable is the val df.
Because it returns essentially returns a tuple, and so you're unpacking the tuple over there. Okay. Yeah. And hold on. And then you tell it the test size. Okay.
And also, so one of the other things, hopefully I still have this open. So you don't have to do that shuffle actually. That is part of the train test split magic.
Oh, okay.
Is it has an argument shuffle that will shuffle the stuff first, and its default is true. So you already are having it shuffle for you.
As a matter of good coding, do you, when you get to this point, you have train df and test df, but you used to have another train df.
So if you look at, I think I did this correctly on mine.
You may have coded something else.
Yeah, so it's called train test split, but the way most people use it is you have your train set validation, and then potentially and then potentially you also have an additional one dev set, and then after that you also have the test set, and there's some arguments for and against all of the different setups, but this is the simplest, where basically you just say, give me some of the data and I'm not going to train on this.
Yeah. Do you, I mean, I guess most people would just leave this as is, right? Like you get to this point, it's called this, you're reusing the name, but as long as you know what you're doing, it's considered fine.
Yeah, I that's typically how I do it, because there's no real reason at that point to keep a full copy of everything, unless there are certain cases where it's like if you want to calculate the mean across the entire set, then next time you do that you have to recombine the two when you're doing that and stuff like that, which isn't
the test data frame that came.
I think
that doesn't have labels, right?
No.
This so this thing doesn't have labels.
No.
So you can only get your stuff from the train data frame, right? And okay, something here happening here. I think I've run into this
I think
times.
I think you split and you accidentally threw away some data. The good thing about this competition is it's such small data that you can just run it over and over.
I think
again.
what's happening is that every time I run this,
It splits some val and ditches the old train. Yeah.
So I'm just going to call it something else.
Have you worked on any of this stuff before? I saw you talking to them for a second. I didn't hear anything you guys were saying.
Basically, I mean, I know some machine learning concepts, but I'm not worked on any active projects or done any calculus before.
Okay. Well, you brought your laptop.
Yeah.
So just get on your laptop and try to join our Slack. It's linked on the Meetup page. And then right now we're looking at a kernel that we put together last week, and we're trying to do some new improvements on it. So far, it's probably something that you probably doing if you have a little bit of time.
Well, I mean, not too much. So basically, but basically, it's a collaborative workspace or something.
Yeah.
Okay. Yeah. Thanks. So you're right.
Yeah.
Dinesh.
Yeah.
Okay.
Yeah.
I think I tried to do the label encoding on the bridge. So okay, so bridge, this is the bridge name, then this is this. But and then I can do a transform so like compare my what element is it, but then I'm supposed to do it.
So now, now you can transform these elements into the stuff in the data frame. So what you need to do is you've got your train DF, I think, somewhere. Yeah.
It is somewhere. Train DF.
Yeah. So if you scroll back down, you can do. I'm trying to think of the best way to do this. Basically, what you need to do is you need to apply that transform onto all of the elements of the data frame of that column.
Okay, so I guess probably in that train there's a column is the bridge, it's the text, and now I need to put this one, the number actually, right?
Yeah.
Yeah. Okay.
It'd take me a second to figure out exactly the best way to do that, but yeah, that's your goal basically.
Okay. Thanks.
important a field to be?
No, Tommy was asking that earlier. You can pick just one and just figure out how to do that, and then we can apply it to the rest later. But for now, just start with any random one. So like try breed one.
This one,
Mhm.
breed one.
Or
Is it-
state or something like that.
Is this already by ID then?
Mhm.
This is already by ID.
Yeah.
Okay, so the question is to make it into one pod.
Mhm.
So what's the problem to solve actually?
So what we're working on is called the PetFinder challenge,
Mhm.
and basically the goal of it is we take in a bunch of variables about the pets, how old they are, what breed they are, and stuff like that, and we're trying to figure out how long it's going to take for them to be adopted. That's the general goal of the challenge. But if you go to the Kaggle page, it'll give you a lot more information about that.
Okay. And where is this space? I mean, okay, do you know you Slack? Okay, so it says.
I'm not sure. I haven't seen that screen before.
Interesting. Okay.
Yeah, but I'll open Slack for a second. So this is basically what it's supposed to look like, and we've got all of our stuff in there. And I just posted our Trello, which has a bunch of our notes, and then this is the Kaggle kernel that we're starting to work on.
Oh, I see. Interesting. You didn't.
Maybe if you click on. Yeah, there you go.
Okay. Okay. Thanks.
Yeah.
question. So, like, go there. So kind of like looking at the data. I mean, so the breeds, colors, and states that was already created doesn't look like it's ever used again, but the train and test already have those categories in it. Do you know, they're already numerically assigned. Do you know how that mapping, I mean, is already done, or?
So they're already IDs at this
Yeah.
point. So that's what he was just pointing out. So the goal here now is to expand it either out to one-hot encodings or the mean encodings like you were looking at.
So even though it's already ID'd, do it again, like with the one-hot encoding or whatever like that.
Yeah.
So not so basically kind of ignoring these which are like named states. Okay.
Yeah.
Okay.
So right now it's already 0, 1, 2, 3, 4, 5, whatever, and we need to either split them out into their own dimensions like we did, where it's like they're each 1, 0, 0, 0, or find the average of that specific category or something like that.
For those, okay.
Yeah.
Okay, cool. All right. Thanks.
No problem. progress on that?
Maybe we'll see.
Which variation are you trying to do?
I'm trying to do one hot encoding. I've gotten a little confused because we're not encoding. We're not encoding the list of the labels. We're encoding the column that has the breed number, like 286. We want that to be a vector, a one hot encoded vector.
So, if you look at the stuff on here, so the stuff that we have is already labeled encoded, right? It's got 307 or 241 instead of like German Shepherd or something like that, right?
It's got an ID.
So the next step is one hot encoding. It looks like you're doing something from scratch, which is good, but there are existing implementations of that stuff, so you don't necessarily have to do it on your own and figure out the entire details.
Where in sklearn?
There's one option in sklearn and one option within Pandas itself.
Oh.
And so the one that I went with right now is using Pandas, and it's called Get Dummies, basically.
Ultimately, are we trying to replace that column with a vector?
Yeah. So like I saw on your screen, one of the numbers was 307.
Yeah.
So what we're trying to do is
zero,
have
zero,
it be
zero,
zeros
except
up
for
until
them.
307, and then that's a 1. Yeah.
Yeah, I was trying to do that from scratch, but maybe.
Want to see what mine looks like at the end. So this is the normal section of the data frame, but then as I go over to the categoricals, it ends up being breed1 underscore 0, breed1 underscore 1, breed1 underscore 3, and so it gives you that information still of what variable was I looking at, but what was their ID basically, and then it marks them as zeros or ones.
So you don't actually have a column that has a really long vector in it. You
It's
have
new columns.
New columns, one for each of the dimensions of the.
That's one way of doing it. I was just thinking about it, and we're gonna have issues in a second with this method, but it's decent enough for what we're doing right now.
Could you, if you were to construct a vector that's zeros except for the appropriate number, could you then replace the number 286 with that vector somehow in this data frame?
So instead of having new columns, you just have a list of the numbers that's just as zeros and then a 1
Yeah, I don't know if a data frame can have a vector as well. It can have a vector.
You can have a list. You can't have an array. Yeah, which becomes problematic when we're actually plugging it into the algorithm. So that's why I did it this way. But the problem with this way is it's only making columns for each ID that we found. So potentially when we go over to the test data frame, we might have a different number of columns because there might have not been a 37 in the training set. So we might have a training data frame that's 500 and a test data frame that's 450 because it doesn't have the same input columns basically. So I'm gonna have to rewrite this and do it with the...
Because here it skipped 8, 9, and 8 and 9 because it didn't have that. But we do have a list of all the breeds. how can we use that? And it's a comprehensive list.
Yeah.
How can we use that to make sure that it does create an 8 and 9 column?
We could do it that way, but the way that I was thinking of doing it was using sklearn's one-hot encoder, and essentially you can do a fit, which will learn every single column that's in both the train and the test set, and then after that you do a transform, which will turn just the train set into those columns and the test set into those columns, if that makes any sense. I think that's the way I'm going to go with it. That's also a valid way. It's just basically saying what are all the options and just make a column for all of those.
Yeah. I'm not sure that I would be able to implement the idea, but doesn't the word fit typically mean that you're actually training? At least in Keras, fit means to train something, right? Here in sklearn?
So in sklearn, pretty much everything in sklearn has fit, transform, or fit, predict. And all that really means is you're kind of grabbing information out of there. It doesn't necessarily mean you're learning anything about it. Because in this case, fit means basically find out how many classes there are and make a mapping between the two of them. It's not necessarily learning anything. Nice.
I was a lot of time to just write that one line.
Well, it's just you need to know what the correct tools are at the different times.
But I have the same thing you have, which is the ones that are missing are missing.
Mm-hmm.
Right?
Yeah. I'm working on that right now. So. I'm getting some weird results that I'm not understanding. Can your cord reach here? Because you can sit right here at the table if you want.
And I don't need this. This is my one.
I think so, yeah.
So we're trying to get into the train, into the training. Instead of having breed one, which was an idea, we need to replace it with a label from the color. Right there, finished. Here's what I did. So, not sure if it's, but I've added the column label to the breeds, but doing the transform on this one. And then I just simply do a left chain between the train here. Actually, this one with the column where I only have like the ID and the label.
Yeah.
And then I got rid of the columns that I didn't need. Basically, I replaced label with breed one label.
Yeah, that looks pretty much like it. And then did you try plugging it into the model?
I don't know how to do that.
Okay.
Yeah. That's the first part. So.
Yeah.
And I think I need to do this the same on the test to replace, to have a similar column.
Yeah.
Like instead of having breed, to have the breed one label in the test.
So that's all correct. You just need to apply it to the test data frame as well.
Okay.
And then after that, this stuff, you'll basically be able to just plug that stuff in. So all you need to do is add the additional column that you want to use as an additional feature.
Okay.
Hey, Ryan.
Yeah.
I was looking at the kernels which people are using. So first they made a list of numerical columns, and then they subtracted the numerical columns from the total columns to get the categorical columns. But then they are converting these columns of the data frame as the type. They're converting the type as category. Then what will this make changes in the data frame? So the values are the same.
Yeah. So what it's doing basically is the part that you're not seeing is that there's data types that are underlying that. So like some of them are float, some of them are ints, and so on. And so one of Panda's data types is category. And so it won't show you anything differently, but when they're actually passing it at the end to like GBM, it will handle categoricals differently.
Okay, so the values which I see as 1 or 2, the data type is category for those.
Yeah.
Okay.
It won't change anything in terms of what you actually see, but it's how like GBM will change the way it handles things in the background. Yeah, that's the only difference.
Thanks.
is the problem statement, right?
Mm-hmm. So that's the one that we're working on, basically.
And where's your, like, I mean, you have seen that basically you have this is your Trello page, right?
Mm-hmm.
So what's the, I mean, what are you, like, where exactly are you guys and what's
So right now, looking at this, what we're working on is we were just adding a validation setup, and then we're working on handling the categorical variables. Those are the two things that we're kind of working on now. And so there's links in there, so if you want to apply the different tools to this data set, you can try looking at the documentation here and then seeing how you can apply it to our stuff that we're working
and
on.
this is all like you posted this, I mean, I see there's a lot of papers in here and stuff like that.
Mm-hmm.
So this is like generic stuff, or is it like something specific to this?
I picked out stuff specific to this competition, but they're general concepts that will apply to anything. But I hand selected them, so there's stuff that's relevant.
I see, but your working spaces here basically, like these are the things that, like, which one?
I think most people at this point are working on the one-hot encoding.
Okay.
So, but I just kind of gave all of the different ways that I know of and that people can work with and try whichever one they want.
Thanks.
Yeah.
Alright.
Mm-hmm.
So here are columns for categories of independent test results. So this line thing, like Japan, it's going to be always 0 in the DF.
Mm-hmm.
Is this kind of like what you're doing?
I was looking at using the one-hot encoder from scikit-learn.
Oh, okay. I'll just continue
I'm
with this.
sure there's a bunch of different ways to do that. I'm kind of struggling with the way I'm doing, so I might look at that in a second. But
I'll keep working on this one and then I'll see if I can make it happen.
Yeah. This is one of those things where it's like it should be kind of trivial, but at the same time, it's like I don't know exactly the best way to do it yet.
Question about Kaggle's Python interpreter.
Mm-hmm.
So, just in this local notebook, I can add encoded columns to this data frame as such. But when I try to do this in Kaggle, they're not included in the test DF.
Can I see the other one that you were doing a second ago?
Hoping it's not just some.
So yeah,
copy
it's just something trivial. So you have train DF there, but if you go back to the other one, you have test DF. Yeah. So that's, you've got it right. It's just a typo. Is this this? Yeah, this is the same one you're looking at. Yeah. Okay. Cool.
Not sure how this train DF versus DF is though.
This looks easier.
Did you figure out this thing here? Like here, you're doing the same thing you did above, which is you had a data frame, you're applying.
Mm-hmm.
I actually don't want to look at this one because they're dropping a column, which I'm not sure why. But here you have a data frame, and you're applying it to a particular column. Actually, well, this is just the prefix that it uses here, right?
Mm-hmm.
Country, country, country. But here they're using two things. They're using a train DF.
Mm-hmm.
But they're also using DF, and I'm not so sure where this came from because it's not mentioned anywhere else before, I don't think.
That might just be a typo. They might have just left it in and it should have been DF.
Oh, really?
What I found, this looks like an interesting solution, is basically, so it's the approach that you were talking about, where we know the various categories because we have those files, and you say, okay, here's the categories, and then let's turn it into dummy variables, so the titles will be correct, right? Because I was like breed1_7 or whatever, and then you can re-index using those categories. So basically, you reset the columns to include the ones that you found using the file that we had before, which I think might be one way to do it.
Is it working on that? Oh, this is just their description.
This is just Stack Overflow, yeah. I have something really quickly to show you guys. So one of the ways we were looking at was the one-hot encoding. And so this is branching off from the kernel that we were looking at before. So we load in the data, and then we had our numerical columns, and then I defined some categorical columns. So the type, the breed, gender, color, state, and then just viewed the columns. And then I did this this little snippet that basically iterates through the categories that we were looking at from the categorical fields. And then it does this thing called get dummies, which is essentially it one-hot encodes those variables like we were talking about. So it'll turn it into 001, 100, and so on. And so it has this nice function that can keep the prefix. So the way it turns out, if we look down here, is it'll turn into breed1 _ 7, breed1 _ 10. So you can still see that their breeds are broken out, and that's the specific variable that it's corresponding to. Instead of just being zeros and ones, it can actually tell you which column that corresponds to. And so at the same time, I dropped the old columns that used to be either text or numbers or whatever. So now that everything is just zeros and ones. So this now is a massive data frame that's super wide because it's got a new column for every single different category of the thing.
What's the dimension of the metrics? The data frame.
So it used to be 25 and now it's 362 because there's like 300 something breeds or something like that. And then we do the train test split like we were talking about, so splitting it into 80%, 20%, and we can see that with the shape down here. And then we can see all of the different columns, so we can see that there's a whole bunch of new state columns down here at the end of the data frame. And then this is just using very basic decision tree classifier like we were doing. And then what I did is I split out the target variable for both the train and the validation set. So they're separate variables now rather than being part of the actual data frame. And this is, I don't know if I would call it best practice, but this is something I see frequently done just to make it so there's no chance that you accidentally leak your target variable directly into your data frame. And so from there, I took the train df and just passed the whole thing in there, all of the columns. And I did the train targets as what we're trying to fit to. And then I did predictions on the validation set after we learned from the train set to create these predictions. And then from there, we can compare our predictions to the actual. So our predictions, our targets, and our weight is quadratic. And so if you guys remember from the beginning, we were getting like 237 or something like that. And just from handling the categorical variables now, we've gone all the way up to 327, which is a big leap. And we can also see down at the decision tree down here, it's still doing that same age split, but then we can see that on both sides it's actually using that breed 1 as one of the secondary splits. So that's an important feature that it's found, is if it's this specific breed of dog or not.
That's actually 307 is the uncategorized, I think.
Really?
Yeah.
It's mixed.
Oh, is it
Yeah,
mixed?
it's
It's
mixed,
a mix.
yeah, it's mixed.
Yeah.
Interesting. And so we can see all the way down that it's actually using all of these different features in the various spots where it used to just have no information. And so that leads us to our problem, which is the way that this this get dummies works is basically it will look at all of the options in the data frame and then it will create a new column for each one. So if it sees 8 options, then it will make 8 columns. But the problem with that is that we don't necessarily have complete overlap between train df and test df. So there might be, we might encounter 50 breeds in the train df, but we might encounter only 35 in the test df. So when we run the same process on the test df, it's only going to create 35 columns because it doesn't actually remember the 50 that we used before. And so our number of columns is going to be different between the train set and the test set. And so that's what we've been working on, trying to figure out a way around that and to make that work. And so there's a few different ways we can approach that, but just kind of putting that problem out there in case anyone wants to work on that and have some input.
Why do you use the dummy, not the one second one?
That's what we're looking at using now. I just used get dummies to start because it was just the easiest way to combine the two. Yeah. So that. Mm-hmm.
You can ignore the ones where you transform the test data instead of taking out to true that it will generate.
Yeah.
Ignore the ones that it's not in the data set.
Yeah, and it also so it will learn from both of the sets and then apply it to each of them individually, so you know you'll have all of the correct columns. So that's what we've been looking at switching to. Yeah.
For the column that you mentioned, is there a way to first merge the train with the validation, run the get dummies, and then split it back and train
Yeah.
the validation?
Yeah,
that's a good
that could work
idea.
too. Yeah, yeah, that's an option. And so one of the other approaches that Leo was pointing out was that we have a complete list. We know all of the breeds that are in there. That's one of the files. And so we could just say create all of the columns and then just plug in the values where it's true. So there's several different ways to cut that. We'll have to just figure out which one is easiest.
did you run into a problem that we're trying to use an integer as a category, where we have to actually convert it to categorical?
I'm not sure what you're saying.
So here, I think what they're doing is they're turning this column.
They're changing its data type to be categorical.
Right.
Yeah.
Our breed is integers.
Mm-hmm.
It's not categories. Do we need to do the same thing?
No, it'll work exactly. Well, when you say do the same thing, yeah, we can do exactly the same, and it'll work like they're saying. Does that make any sense?
Well, I was running into
it will work, yeah.
I was running into a problem here. I was trying to make this part work. I'm not exactly sure what they're trying to do, but they seem to be getting the column from the training data. And what I'm trying to do is I am feeding it
the list of categories.
Yeah. Which I checked, it comes out as a list, which is what the example was showing. I'm not sure whether this is correct, but it does tell me that I'm trying to use the wrong way of accessing a slice.
Do you have I doubt that's going to be it, but categories, blah, blah, blah. Let's try running that again. I get that error all the time, honestly, and I usually just ignore it.
But it didn't do.
So it did.
Or maybe it did it.
It did do what you wanted it to do, but it's not going to show up as dummies yet. At this point, you need to turn it into dummies. Yeah, so like your next line will be the step that actually turns it into dummy variables, the 0, 1, 0, 1, wherever.
Oh, that's right.
Yeah, so if you run the step below, it should work now.
Oh, yeah?
Yeah.
Oh, wow.
So that's one option, and I just did the other option, so we can show both roots now. There's more than 2 roots, but
Aren't there a few breeds in the training data that the breed ID equals 0 and there is nothing in the lookup table for that? And it turns out it throws an error saying, no, couldn't find that. Should I simply assign a label to 0, or can I leave it 0? Assuming that it was not used 0 for another label.
yeah, I would say that's probably fine to basically just leave it as it is. I just got working the method that you were talking about, which is basically you combine all of the data frames and then you know all of the possible values, and that ran perfectly fine. I like that solution, so I did that and it's working now.
How do you know after you merge which data came from it? You just put another column with a label like this is training, this is validation, or?
So it's pretty simple because you're just stacking them vertically. So basically I just said take the number of columns that were originally in the train and take the number of columns that were originally in the test and just cut those back apart.
Okay. So it's a lot simpler, yeah.
everything we did for train DF, we have to do again for validation DF, right?
So the trick with that is to do it before you split them. Yeah. That's easier than needing to do everything twice.
Yeah, it's more clean.
Flood alert.
Close to the river. Well, it looks alright.
But that's the definition of flash flood, right? Yeah. It looks alright and then it doesn't.
The road down that way actually has a specific road sign that's just always there that says like, careful, this area floods specifically. So hopefully when we drive over there, it's not totally washed out.
So we should do all this for the concatenation of the train and test, and then later on we split the train into validation and train, so everything has everything. Everything has all the columns, right?
Thanks, Ryan. I need to get going, but that Slack thing, I should be able to access him from anywhere, right?
Yeah.
Thanks.
Yeah, no problem.
Oh, it's going. I was curious if like any of these would actually like yield results. I split all the data up and I'm just trying to see that is it actually gonna like make nice zeros or something in my quarter. Now I'm trying to figure out how to NumPy no. Obviously going for that.
So you're trying to do the meeting coding one?
Yeah. Okay. Well, I was just curious which columns would actually even like yield something that's worthwhile before even trying it.
Yeah.
So that's why I was like, well, I'm just gonna split them all up and see which one could do it, and then try for that. And then
yeah. Okay.
But I'm not too familiar with plotting data, so I'm not reading that. But
do you have anything specific you're struggling with?
No, just really like the syntax.
Yeah.
Like,
Okay.
you know, how do I put it into this array, and then like, you know, how do I get to it the way I want to?
Yeah.
So, just reading syntax, fun. Good game.
How would you calculate the mean of the Because in this data we have like a five, it's not like a binary classification. It's like a 0 to 4. So in the case of how would you calculate the mean?
Well, then, yeah, right.
Oh yeah. Well, I think that calculation. I mean, it just depends on what you're doing it because it's depending on which not algorithm but method they use, like likeliness or the other. You're just basically taking, your number of values, like given at the numerator and then the different ones at the denominator from 0 through 5, and then that's calculating the mean still. So I mean, it's still if I'm understanding that correctly, it's still the mean regardless if it's binary or not. You just have a bigger denominator or average, which is then it's going to classify from there. If I'm understanding that correctly.
Well, this allows to calculate means by grouping. There is a command which allows method, I think it's actually called by grouping.
Okay.
So the way our data, the targets come in, right? It's 1 or 0, 1, 2, 3, 4, right? So if you take the mean of all of those values for a specific group, you'll end up with a value that's like 2.7 or something like that, because you just basically add all of them together and then divide by how many rows there were that had that specific condition, right? Because it's different than the way they were talking about it is you just take the count, but what we can do is we can take the sum. And so if there's a bunch that are 4s, then it'll skew it higher, but if there were a bunch that were 1s, then it will put it slightly lower.
Oh, okay. So in the case like if certain like a breed type doesn't have any count, in the case you divide like 0, right?
Yeah.
So in the case of what you assign the value in there, is it like it's kind of like infinite or just like 0? Because since 0 is a very early adaptation rate, so you don't want to.
Yeah. I would say maybe just fill it with the mean or something like that at that point.
Just random value.
Basically, yeah, because
because
I mean, the condition that you're talking about though is saying that there's no row where a certain breed occurs.
Yes.
And at that point, then we don't have to worry about it because we don't know anything about that breed, basically. So I would say you either, potentially you leave it as, I would probably say just fill it in with the mean of all of the different breeds. So you say, we don't know anything about this breed, just stick it somewhere in the middle. So like we have the mean target for German Shepherds. I think you might have missed the beginning part. So what we were talking about is target encoding. So like one way of handling the categorical variables is like
which category you are doing for the mean targeting?
Well, so I basically split up all the data I'm going to do in all of them. I split up like the columns for like age and breed and all that stuff like that.
So you have the
apply
category
differently to see which ones would be worthwhile and which ones wouldn't.
And one way of
So that's what I was
representing
doing.
that information through that category is
That's what I was doing right now. So
what
I
is the
created
average
every
price
variable for like
of
age or breed
all
1
of
or
the
breed
different
2.
kinds of shoes,
And then I'm using that
and
to
then
kind
that
of
would be
plot histogram
different
to see which is going to be worthwhile or not, which is actually going to give us like
compute
good
or
data.
something like
Because the ones that are
So
that's not going to give us good data, I don't want to try to train the data on that. So I'm just trying to see right now which is actually going to be
Oh, okay,
for the categorization.
So you're trying to like select which one is the best.
Yeah.
Okay.
So, well, that's what I was talking about earlier about. Because now I'm trying to plot the histogram to see exactly after doing that, which one's going to provide the valid data that could be worthwhile and not overfit or anything like that. So we'll see what that results. So I just did it for all just to kind of see.
And you find that average is 1.5 or 2 or something like that, and then you just plug in that value. That's another option. I'm just it's just a bunch of different
for anyone that's looked at the age, why does it go to 255?
Months.
Months. Oh, okay. Because I was like, what? What is this? Yeah.
Yes, months.
Okay.
It's still 20 years.
Yeah. I was like, this talks.
You didn't know cat food is good for you?
Yeah. I gotta switch it up.
District 9, isn't that the movie where?
Where the cat food is. Yeah. Well, I was thinking like maybe it can't be human years. Maybe this is like dog or cat years. But then 255 still is like really old for an animal or human.
Hey, I merged them at first. Then after I did the transformation, I broke them apart, and then I broke that one to this two.
Mm-hmm.
How did you end up having this validation measurement, which I commented out somewhere, but here. You had val df, which means that you got it from probably while you were doing the tree, when you were constructing the tree.
Yeah. Let me show you on the TV. So this is all the same stuff, basically defining the columns. And then from here, what I did is I concatenated the train df and the test df, so they're all one piece now. And then from here, what I did is I made the dummy columns, but I did it on the entire set, basically.
Of categorical columns.
Mm-hmm.
Why are you doing this on the train df and the test df separately?
So the way that, so this is what we were talking about before, where in order to get valid dummy variables, you need both of them squished together, basically, right? So that you have all possible train and test things for the categories. And then, so I compute that, and then this is far too complicated of code. I could have done this in more lines, but and then from there I'm grabbing the rows of the train set. So that's the dummy variables. That's the 0, 1, 0, blah, and then I'm concatenating it to the original training df. So I'm taking what originally was that one data frame, and then I'm concatenating all of the rows of that original, but the dummy variable version. And that's what becomes the new train df and test df with all of those things.
I don't know what's going on out there, but
yeah,
it looked pretty bad. But you have the list of breeds without having to concatenate. Oh, we're not just doing breeds. You're doing every categorical field.
Yeah.
Okay.
This is just it's a pretty general way of doing it. It's not pretty. I should have split this into more lines so it's actually human interpretable.
Okay.
And then from there I draw to the original columns that we don't want anymore.
Why didn't you use the list of your list of cat fields to drop them?
I did.
Oh,
I did that, and then I did some of the other ones that we don't want to drop either. So these are the original categorical fields that we just made new columns for, so we don't need those anymore. And then we also have these various fields, which we might look at in the future, but right now we're not using them. And then here's random other crap that I'm not using. And here is the train test split. And then I split the target out, and then I dropped it.
Wait, what are you doing there?
So this is our target variable, making a variable for that, and then I'm dropping it from the data frame. So I can pass the entire data frame to the algorithm, and it doesn't have the target still in there.
Answers in it.
And so I don't have to say anymore.
That's a mistake I just made. I just realized I'm passing it in a entire data frame, so I'm actually passing it the answer.
Yeah. So that's the reason I do that, though, is now I can pass the entire thing in, and I don't have to say pass the entire thing in, but only these columns. It's just an easier way of doing that, basically. And then we do the decision tree classifier, and we fit it with the train DF and the train targets. And then from here, I make the prediction on the validation DF. That becomes my validation predictions. And then I take the test DF, and that becomes my test predictions.
Yeah, that's the stuff that I think I need to. Oh, actually, I don't think it was passing. Whoa. Look at it, was falling out of there.
Yeah.
I don't think it was passing. This thing here may have been. Oh no, that was just a single. Never mind.
I found this interesting tool that allows you to essentially do like a screen snip where you basically just drag it across something on your screen. It's a browser extension. And so you just drag across, and then it will OCR that region so that you can pull whatever text off. And I was thinking about how interesting it would be to do like I'm not sure how you would do this, but if someone is like doing a coding tutorial on like YouTube or like somewhere else, if you have it specifically set for that region, it can just keep OCRing, and it can give you live updates of like actually usable code, so you don't have to like re-transcribe it or anything, and it would just be going live as you're watching the video.
But whoever like makes a video for tutorial, they always post the code, link to the code.
Yeah, typically, but sometimes they don't. But the other problem with that is that if they're like scrolling around and stuff like that, then you end up with issues where it's like, how does it keep track of where they are in the page?
Am I scrolling up a little bit? Okay, that hasn't changed, that one.
Further?
So CL fit train, you do the train. After you drop the column, you do the train, data frame with the train target. So I don't have that because I don't have those. Yeah, let's go.
My friends wanted to go on a hike, a potato chip rock. I don't know if you guys have ever been there. Yeah, they were like, "Oh, it'll be perfect. No one else will be there," and it's like, "Yeah, but we might die." So.
Details.
Was it raining at potato chip?
What?
I know I like San Marcos.
Mhm.
It's pretty clear skies.
Yeah. I don't know.
What's axis equals 1? What does that do?
Columns. It means that you want to drop the columns, not the rows.
Oh.
Yeah.
Okay.
Do you run that for a second time? Because if you run it for a second time, it's already been dropped.
Yes, it is right.
Right. Like if I convert to like read one to the like, mean target coding, so the range should be 0 to 4, right?
Yeah. Yeah.
Is there any like template or some skykit learn like to just automatically convert?
So in that video we were watching, they had a little code snippet that should be able to do it for you. Basically, it's like 3 lines of code. So you can basically the video is on the Trello, and so if you go on the Trello and look at the video, there's some lines of code that will show you exactly how they did it.
Is it Coursera or?
Yeah. Yeah.
Because I tried to convert it manually while it takes.
Yeah. Yeah. I tried doing it recently for something else. I forgot what. And I remembered I had done it before in a previous competition, and I like just could not figure it out. It was like too many group buys and all that stuff, and I was like, I give up. So it should be in that video, though. It should show a relatively easy way of doing that. Once you get that done, then we can make a submission.
Yeah.
We can show how to do that.
If I add 2 lists, I get a list, right? I can concatenate. Oh, maybe I can do append.
Go scroll down on that error and see exactly what it's telling you. So it's telling you that you don't have adoption speed in there.
Oh. Oh. I want the validation. I want the train targets.
Yeah. Yeah, exactly.
Do I still need the column?
No. Now it's just a list of numbers basically. It's not a data frame anymore. Scroll down to the bottom.
Actually, are you sure it's not the data frame? Because
so what happened here is you saved it out to a variable train targets, and then you dropped it from there. So it's no longer in the data frame at all.
Oh,
but it is in that variable, so you can plug that variable in and say train targets, and then use that. All right. Bye.
Wait. Should I have set train targets drop? No. This is train targets. This is the original frame, and I dropped it. So now I have this and this. Same thing here. What am I feeding into this?
Scroll down. Input contains NAND infinity or blah blah blah. So there's somewhere where you have an empty value or something that is way too big. So
well, let's go and take a look at what I have.
Pull out, yeah.
Let's just look at the head. Train targets.
I'm pretty sure that's not where the issue is coming. I'm pretty sure it's coming from the train df. So if you do train df dot is na,
like that,
I think it's all lowercase. And then I think from there you can do sum with parentheses after, yeah.
Is an a what?
Open close parentheses, and then after that dot sum.
Like that?
After the parentheses. Sorry.
So, okay, so we were calling the method and then...
So basically what we're doing is we're finding how many rows are blank, and then we're counting all of them.
Okay.
We're adding all of it up.
And this is also a function?
Mm-hmm. I believe so, yeah. So that's telling you how many of those have null values. And so we can see that name is the area where we're having issues. Description, breed one. I'm not... So what I did is I just dropped all of those, remember in mine?
Yeah.
Because I dropped the variables that we made into one hot. So if you want to see, that's all of the stuff that I added to the stuff that I dropped. Remember?
Yeah, let me make a list of the ones to drop. And I can just maintain that up here. Breed one had some of there. Okay. I can't drop. Oh, I can drop that.
Yeah, because you already made it into one hot. That line isn't actually running, I don't think.
This one?
Because the one above. Because adoption speed is already missing. Yeah, so it's erroring out. It's not actually dropping the new stuff.
Oh.
I would just basically run it back from the top.
Yeah.
Just scroll back to the top and just hit run all the way to the bottom. With this stuff, it's nice. I just committed one of the kernels, and it took 11 seconds to run the entire thing, so it's pretty forgiving.
Yeah, how do I run the whole thing?
We can do that one, but what I typically do is just shift enter the entire way down to the point that I want. Normally in Jupyter Notebooks, you have the ability to say run all above, which I use all the time, but you can't do that in the Kaggle ones that I know of.
So 178 run, and this is benign, I can write again. 179, when I get here, oh, must be string, not a list. Oh, the thing to drop requires
mine's a list. So I'm adding a list and then a list of strings to it.
Yeah,
Does that make any sense?
And mine is a oh. Oh, that was dumb. It needs to be you're adding a list to a list, right?
Yeah, that should be it.
But it says must be string, not list, as opposed to must be
I
list,
think
not
that
string.
error was happening because you can't add these two together.
Oh,
not necessarily that it's not
I see,
understanding the
I
drop step.
It just started with a string, and I'm trying to add something to it, and it tells me it must be a string, not a list. But
Yeah.
giving me a list.
And then you're also going to want to drop the name column and description probably, if you haven't already.
It's in the list to drop.
Oh, okay. I didn't realize you had made that.
Yeah, I put them here.
Okay.
Rescue ID, name, description, and pet ID.
Yeah.
But I still have a problem. Let's see. Invalid syntax, okay. Okay. It took it, right?
Mm-hmm. So now run the below line and see.
If I run this again, it will give me problem.
It'll error out
because it already removed those.
Yeah.
This one, do I need to run this? I mean, I don't need to.
You don't have to, but it's probably a good sanity check just to make sure it actually dropped the stuff that you're thinking of. So now you just have zeros all the way down, so you're good to go.
Okay.
Cool.
And so here, I don't need my data frame now has everything I need to have. So train df train targets are all bottom. Train targets and train df.
Yeah. What does it say at the bottom of the error? Could not convert string to... Oh, we have one more thing in there, which is, remember we added the additional column that tells us whether it's train or test?
Yes.
We need to get rid of that.
Oh. Data type.
Yeah. You can probably just remove that from the beginning of the kernel because we don't need
Well, I actually use it.
Yeah.
I use it to split the things later on. So what I'm going to do is I'm just going to add this to the list of columns to drop later on. So now I'm going to
Do you happen to have the piece of code that was computing the score? Is it posted on Trello?
I can copy it over.
Okay, thank you. Or just put it in the Slack.
Yeah.
Thank you.
Yeah.
I don't know if anyone's parked over on this side, but it's kind of flooded, so you may want to, if you are.
Actually.
Yeah, I was like, I think I parked over there. Now I'm not sure.
Yeah, it's very deep. We didn't realize.
What's going to be the focus next week?
I think the focus will be on gradient boosted decision trees. And so I already have a couple links on the Trello board. And so basically the gist of that is right now we're just using one decision tree. And so that's going to be using a whole bunch of decision trees and averaging predictions together. So that'll be the gist of next week.
Okay. That's me.
That's rough.
I'm moving that now. Right.
Bye.
So it's just that part of the parking
Yeah,
lot.
just the side. Oh man.
Ooh.
That's starting to get to the height where it's like a couple more inches and it's like
Inside
going in
the
your
car.
car when
Oh,
you,
shit.
yeah, that's...
How about the other side? Is that
The other side's totally fine, it's just that side is kind of annoying.
I decided not to park there just in case. I was like, that's
Yeah, I saw that. I'm like,
I'll have to walk a little farther, but no one else had parked there.
Yeah.
When I got here, I was like, maybe they have the right idea.
Yeah, does anyone mind giving me a ride to like UCSD after this?
I can do it.
You can do it? Do it.
Sure.
How'd you get here?
I just I took a lift.
Oh. Did you walk?
Everything good?
Oh, it's deep.
We should have offered you my umbrella.
No, I'm good. I was just curious, but yeah, I know, right? Yeah, unless you can float on there.
Yeah.
Alright.
Okay, only if you're like Mary Poppins. Which columns are you target encoding on? Or just
Well, that's what I was first trying to figure out which ones I should even try this on. So I found a few, and now I'm trying to do it. But I did it for, well, age, I thought it was a good one. That seemed to like have some correlation with the adoption speed. And then the other one I found was deworm, which makes sense. But I've only gone through like 3 of them so far. But now I'm just trying to like actually implement it, and I'm having difficulty with it.
Oh, yeah.
Yeah.
I've been looking at embedding and the code is really nice.
Yeah, that's why I'm like, okay, how do I, what, it did something. Something was done.
Like, I missed the old, like, SK learn, where 3 lines of code. I'm looking at Reddit now. Paris, entire.
Oh wow. Yeah, I was interested.
Is there actually a function on scikit-learn? How does it work?
There's I think this web page.
Oh, okay. Sorry. There's a targeting code.
Yeah, exactly. Yeah, that's what I'm using. But I don't know if it's alright.
Where did you find the targeting code?
It's from this category encoders.
Okay.
So that's what I was using. And and then from that there's a target encoder.
Okay.
Oh, I was looking at the video. I was like, this guy's on the video's not using any of these ones, but I just found it online. So I was like, all right, I'm gonna try this out.
Yeah.
So what's the right one to use? Or that mean or whatever? I don't know.
I don't honestly have an answer. I haven't done that yet. The thing that they showed in the video seemed to work reasonably well, so my inclination is just to use what they had.
Yeah.
But
I couldn't find at least how they were doing it. So then I looked online and I found a target encoders from a category encoder from scikit-learn. So I was like, okay, this should be similar.
Yeah.
But it's not working at least.
Yeah.
So I mean, I'm just gonna keep figure it out.
Alright, I'll try what they're doing.
I know that there's one built into H2O.ai because when I was researching this stuff, that was the one that popped up. But the documentation I found was in R, so I don't know if there's a Python version as well, and I don't know if that package is even on the Kaggle kernels. But they had something that would do that in H2O. So
yeah, that was the first Google hit. So then I was like, I just want to work within scikit-learn.
Yeah.
So I was trying to find something else to do it.
Yeah.
Is it a good practice to drop all these columns from the test set data frame as well? The one that you're gonna use to.
So when you make predictions at the end, then you're doing it on the same data.
Yeah, I ran into the problem where I was trying to make a prediction on an item from the test data set, and it was trying to convert the description into float.
Yeah.
And so I think.
So you have to make sure it's consistent across both of them.
Now, do I have to check whether that one has the adoption speed? It would have the adoption speed in it.
The
as a
test
column.
doesn't have adoption.
Well, I produced them from concatenation. I concatenated the training data and the test data, did all my transformations, and then I put them apart based on the record type column. So I need to, I think, maybe do the same thing over there.
Can you show me where the ball targets are defined?
Yeah.
Huh.
Can you check it out? Is there any more about it?
There was a web for it. Yeah. Same for flash flood warning. I don't know if they have which parts. That'd be a useful one too.
I asked my friends if they still wanted to hike, and they said, yeah. they said ponchos, wet hiking, and some Mexican food at the end sounds like a good time to me. I don't know about that.
So just go for the Mexican food.
Oh,
there was that.
Oh no.
What's happening?
That's here.
When Apple moved into their new campus in Cupertino, lots of people walked into
Yeah.
these types of
We've got to get some sandpaper and just scrub it up so it's not so clear. This has been an interesting day in here.
Yeah, so much going on.
Yeah, delicious.
Do you... Wait, this won't work. I dropped the adoption speech from validation DF, right?
Yes.
Yeah,
So
I
use
just
val
left
targets.
Val targets.
Yeah.
Oh, that's right. It used to be there as that, and now we'll have it as a separate thing. So validation predictions, then the targets, then the weight quadratic.
Boom.
Wow.
Perfect. First try.
3.5 hours try. And then I can continue, right? Oh man.
So the problem here.
But we actually don't use this, right? Because I think we end up.
So just go back up and let me. So the problem is that we use list of numerical fields, and now we have more than that, right? So what I did instead is I passed in traindf.columns. So it's giving you all of the column names. Yeah.
So instead of passing the list explicitly?
The class names is fine. The feature names is the part that you need change.
Yeah, okay. Is that a function?
Columns. No.
Like this?
No. It's just like that. You don't have to, no parentheses.
Okay, so it's okay. Now, do we actually use this? Because if I remember correctly,
I don't think we do, but I don't know. Might as well. You're gonna have to do that again at the lower portion, but
okay. Here. Was it train targets?
traindf.columns. There we go.
I brought the braid. Now it gave me another.
Sterilized. Interesting. Did you add sterilized to your numerical columns?
I don't think so. No, it was whatever you have. I didn't add that.
Yeah.
But I'm not removing it either. And you're not removing it either.
I think. That's interesting.
Look at
I might have used. Let's see.
Yeah, sterilized is in here. But you used multiple. How many categorical columns did you process today? Because I think I only processed one.
Oh yeah, that is part of it. I did 387.
Oh, good. Or
I have 325.
Yeah, so you're probably missing some of that. You're just using breed one. Yeah.
As my categorical column.
Yeah.
Which means that I'm not dropping a bunch of other ones. Probably could be.
But that's interesting because that means that we started at like 0.237, right?
Is that what it was? I don't remember.
It was something like that. I should have kept track, but I didn't.
Yeah, I'm fine.
But if you look at your accuracy,
it's slightly less than yours, right? Where is it?
I think it's up a little bit. Yeah. But you're able to get 304, and all you did was add in the categories of the breeds.
Yeah.
And so I have the categories of breed 2, color 1, color 2, all of that stuff. So I actually have more features than you, but it only seems to help a tiny little bit in comparison to you just added breeds.
I didn't just add breeds though. I think I added all these categorical columns, but I'm treating them as numbers, like sterilized.
So if you added those, then you can view those as categoricals or numericals, because when you think about it, like some of those variables like maturity size, 0 or I think 1 is a really small dog, 2 is a medium dog, 3 is a
Yeah.
bigger dog. So it is technically numerical, even though the
Sure.
way they binned it is categories.
Sure.
So it's perfectly valid to
They
use
are
those as
they're
numbers.
ordinal.
Yeah.
Meaning that that there is an order to them.
Yeah.
Right.
Yeah.
So sterilized, what is it? Is it 1s and 2s?
It's the same as the other ones where it's like I think 0 is like unknown, 1 is like partially sterilized, and 2 is like they got everything basically. So it's the same kind of thing where it is still ordered in some way. So I think it's perfectly valid to treat it like that.
Mm-hmm. But I think what I'm getting from the difference between yours and mine is that if I turn some of this into categories, I might get a score that's better, even though they're the part of the model being treated as numbers. But if I turn them into categories, it might work better.
Yeah, yeah. And so this will be probably our last step for today. Is I actually have this step down here. Where did you do test predictions yet?
No, I did
okay. So try to do the test predictions, and then we can actually output a prediction in the correct file that they're expecting and everything, and then we can make a submission.
Oh no, I did. Oh no, I did a single test prediction. Oh no, I did test predictions.
Mm-hmm.
So now I just need to submit them.
Yeah. So now we need to write it down to a file.
And I can submit them before I look at the tree, right?
Yeah. Nothing's gonna change after that. So basically, what I did here, this is pretty standard on Kaggle. Is basically you read in the sample submission file, and what's in there is one column is the ID of all of the different pets, and then the next column will be all of your predictions, basically. And so what I did is I loaded in that file, so it's got the pet ID, and then the answer is blank, basically. And so from there, I just plug in my answers, and then I rewrite it to a file called submission. And then when we actually go to submit, it will look at that submission file, and then we'll look at that and grade it.
You never mixed your test data though with the rest of it. So when I separated them again, I guess I can just look at the beginning of that. I just want to see whether so this is the ID of the pet?
No. So we dropped the pet ID. That was an additional column. That wasn't necessarily the index. And so that's why I have to read in this file. We assume that the rows haven't shifted or changed or anything like that. So what we're doing is we're reading in the file that has the pet IDs, and then we're concatenating essentially our answers, which we assume to be lined up.
Yeah, but how do I know that the answer for this pet really does correspond to the same row in the submit CSV? How do I know that I haven't shuffled things enough here?
You just have to know that you didn't truffle anything.
Okay.
There's not really any reason to ever shuffle your test.
Yeah, I didn't. Yeah, I didn't do that. It's only I took it out. I took the part out.
Yeah.
And only the split, like you said, it automatically does the shuffling. Okay. And I did read that submit early on. But maybe I can remove it from up here and just put it down where it actually is being used. So I have this. I don't need this anymore, right? This was up on the top, but I don't think I need this up here because I'm not using it anywhere. I can just grab that and use it where you're using that, right?
Yeah.
this first.
Worked. There you go.
Just gonna add the next one here, which was submit to CSV.
You named yours sub_df, so you just have to make sure that's consistent.
Wait. Oh, sorry.
That's perfectly.
Yeah.
It's fine to call it that. Just keep it consistent.
CSV. What's the index? Whether it's going to add another column for index or something?
Mm-hmm.
So now I have a submission in there?
So now you have to commit, it'll rerun all the code, and then with that version, you'll be able to actually submit to the competition.
This percentage, what does it really mean?
The Cohen Kappa score?
The 31. Yeah, what is it in practice? Like, how would you translate it into?
It's not the most interpretable thing, but basically it's a measurement of the technical thing is inter-operator agreement or something like that, but basically the example that we looked at was were you here when we watched the doctor example?
No.
So we watched this video where basically they walk us through, there's two doctors, they're making diagnosis of a patient or something like that. And you're looking at how much they agree and how much of that is beyond chance. That's kind of the core of the Cohen Kappa metric. Basically, it's in the Trello. If you want to
maybe it was last week, because I do remember talking about the chance, excluding the chance from the, and I remember it on the whiteboard too, I think.
Yeah.
Okay.
But basically, a 0 is a value of you're agreeing, but it's only by chance. It's we're just going to assume that most people don't have cancer, and so you'd have the same agreement between a trained doctor and a little kid. Versus if you have two trained doctors, you might have agreement that happens beyond just what would happen by chance.
So what number do you want the Kappa score to be?
The best value is 1. So you're aiming for as high as possible, but it's also possible to have a negative number, because if you have more disagreement than just by random chance, so if, for example, you have people who are acting more erratically than should, just given the probabilities of the different predictions, then you could end up with a negative value. Your thing finished. Do a submit.
Where?
So click on that commit, G14, yeah. And then do open version, and it will open in a new notebook. And then if you go to the output tab, submit to competition if you want to.
Why not?
I think we should go for it.
Whoa.
So expected an int, but it got a float. So I think we just need to turn it into an integer, because it's got 2 and 4, but it's 2.0 and 4.0.
I see.
I spent 2 hours.
I see.
On that kind of
Selections.
bullshit. Yeah.
So now what the predict function does is it outputs an array. It doesn't output a data frame, so you can't do head anymore.
Oh.
So you would just take a slice of it or something like that. So you'd say test preds and then up to the 10th.
So I can
value
do entire slice.
Like
oh, to show you mean?
Yeah.
Just to show.
Yeah.
Okay.
Yeah,
And then if I wanted to convert it, I would just say the entire array. Is that I would have to do that?
So the way that I would do it, this is what I did. So you do as type int, and that's all you have to do. It'll just take the entire thing and turn it into an integer. And so you can double check that if you want by just taking that line, pasting it down here, and then you'll see that instead of being 2 dot 4 dot whatever, it'll be just 2 and 4 and whatever.
Yep.
Yeah. So that's all you need to do, and then it should be a valid submission.
Okay.
Hopefully.
Can I? Oh yeah, because it gets the new copy, so then this should be fine. And then this I'm just gonna remove. And then this I'm gonna remove. So now I'm gonna commit this in sequence. Yep. So that
Nice.
was good.
Nice.
All right.
Nice.
764th, is that what this means? That's great.
So we are already better than the group out there because they have been working for 6 or 7 weeks and have yet to make a submission.
Oh yeah.
Is that what the core is like?
Yeah.
1.3 million.
Did they not hear the CEO say you have to make a submission?
I've been trying to tell them, but they haven't been listening to me. So
they wanted to be perfect.
They're just doing a lot of experimentation and not.
Well, once you submit, that means everybody can see your.
No.
Oh, because this is just a submission of the results, not a publication of your kernels.
Yeah. Yeah.
Well, there's also like you only have so many submissions you can do
per day.
Per
so
day,
you can
is that
do
what it is?
5 per day. Yeah.
Oh. Is there how much you can do over the 3-month course or?
It's just the same. It's as long as you don't exceed 5 per day across that entire frame.
Yeah.
So that's typically not an issue, but if you're like combining teams with other people who have been doing their 5 per day, and then you try and merge with them and say they've made 35 submissions and you made 35 submissions across 7 days or whatever, then you have to wait an entire week until you can actually team up because combining would put you over that limit.
Oh wow.
Yeah. That's one of the struggles with having big teams is then you have a lot of submissions and then you don't have room.
So did it actually calculate a different?
So the way that the leaderboard works is there's a public set and a private set, and the public set is essentially the stuff that you get feedback from on the leaderboard, and then the private set is an additional amount of data that we made predictions for, but we didn't necessarily get a score back for that. So in theory, we could like massively overfit based off of that information that's there. But then when we're exposed to the entire test data set, then we might end up somewhere entirely differently because we just memorize the stuff that we have public knowledge of, basically.
So this number, I never calculated this number, right?
No.
I only calculated the number on my validation.
On your local validation.
My local validation. And I certainly couldn't have calculated on my test data because I don't have the answers.
Yeah.
But when they get my test predictions, they add it to another set, you said, and then they calculate the score on the entire set.
Yeah.
I see. It's all about, like, you get all your data, you carve out something for testing, and then from the remaining, you carve out something else for testing, and then from the remaining, you carve out another thing for testing. Because they carved out some of the data for their testing that we never saw. So are you on this, Deborah?
That's what I was just highlighting. I'm in 50.
Oh, was it you?
I haven't. Yeah,
Nice.
I haven't done a submission in like 2 weeks. There was a point where I was third, but I haven't actively been working on that. I've been working on the Quora one.
Just screenshotting that and tweeting that if I was third.
That's the entire goal. I was telling them a second ago is like I get the email that a new competition came up, and I'm like, okay, I'm not working today. I'm just rushing for the
So
for the 75 seconds in first.
Did you get one in this one?
Just thinking about that. Just to stop, so I'm just wondering, my update is, can you click this? This one? Thank you. Yeah, I just want to verify their pictures or I just uploaded the target encoding vision.
I can see the
Yeah.
access
The
bar.
bar. Oh, click. Okay. Right, I just uploaded my histogram before, like a breed one. So before the encoding and after encoding, you can see the distribution.
Yeah. Is that what
There
these
are
are?
two, yeah.
Yeah.
And then
Oh,
you
why
can open
that's-
open the in new tab.
Huh.
I think it takes some time to load every.
How did you basically just copy paste this from your kernel into there, or how did you make this?
I just made it manually.
Yeah.
Yeah, because I just every single point I count, the type and breed together. Once type and breed match to the like breed library, I count them. So basically, I make like 5 different column for like 0 to the 4, and then calculate the mean value. So just add it to the. So this is before the encoding, and after encoding, the span is from 0 to 4.
So they're all within this range. It looks like they're in a more central, normal distribution.
So yeah, I actually want to figure out like how this, the transformation affect to the final result of the thing is after the flow. I just lost. Yeah. I just see I think it's kind of like a transformation of distribution. So from my perspective, I think it's really good to, for target encoding, the thing is, just in case when we have very limited features, this target encoding might go for like overfitting.
Yeah.
Because, it's the target encoding is based on like a level, target levels.
That's one of the problems is if we have a category that, let's say, it only has 1 or 2 or 3 of that specific breed, and we're taking the average of where that should end up, we're basically just giving it directly the answer for that specific sample. I think that's what you're saying. And yeah, that is potentially a problem. So it might be that we only want to do that for certain ones that we have above a certain frequency, because otherwise we're just giving it too much information.
So were you actually able to put it into the model to see?
I couldn't put it in the model.
Yeah, I was like, I'm gonna have to work. I'm gonna come back next week and I'm like, all right, guys, halfway there.
Yeah. There's even, we touched on the majority of them, but there's plenty of additional ways that we can handle this stuff too. One of the things that I was thinking about was like when this is just like, it's not even a statistical thing, but it's like if a specific city has a lot of cats and not many dogs, that probably means it's going to take longer for the cats to be adopted, right? Because there's so many cats and you don't know which one to pick, and if there's only one dog in the city, then that one's probably going to get picked because someone's going to want specifically a dog. And so one feature that you could also pass in is what is the distribution of dogs versus cats? What's the ratio between the two in that specific city or something like that? And there's all kinds of different ways that you can basically encode the knowledge that we have about this problem into it. So lots of interesting ways to look at it.
Who did subject means you did. What you did with breeds, because not all breeds which are in the train set are in the test set. I have missing values.
From what I saw from the graph site, I ignored breeds because I didn't really find that target encoding would actually do that great for it. I'm just kind of looking at a histogram. But I found it decent with age, and then was it deworming and another one. But I only looked, what are the ones I look at? So I ignored breeds. I didn't try it without it, but I might just do it anyways just to see what happens. But yeah.
I may include, just average for the whole data. At least I will keep the data which I completed. And besides, it took me a while to figure out that I can merge. That I can use merging for this. So I don't want to waste all my effort.
Yeah, I agree. I hope this results in something.
So for yours, were you able to put it in a model yet, or you still?
Well, so I'm able to fit it. So with this, so there's this categories and quarters from scikit-learn methods, and one of the methods is this. You can actually do the target encoder for it. And so some functions from that is fit and transform. So I can fit it for some reason to the object that I've created, but I can't transform it to actually add it. So I'm trying to figure out what inputs I have that are messed up. Like maybe it doesn't accept series and I have to put it as a list or something. So I was trying to find examples, but for some reason that wasn't working.
Yeah.
That's kind of where I got to.
Yeah.
But I keep getting errors that saying like index or wait, what is it? Error? It's like invalid access, can't do duplicate accesses. So I'm not sure why.
Yeah, I haven't heard of that error before.
No. But that's the point I got to.
Yeah.
But hopefully I can get that going and then try it in the data and then.
Yeah.
we'll see. But you guys you sound like you made progress.
Yeah, we got all the way to a submission, and that, I believe that's public. It should be, because that kernel started public.
Yeah, I kept editing in the public kernel.
Okay.
Yeah.
So now we all have that public kernel that we can look at, and that's kind of our baseline that we start from. So.
Cool. Where'd you get place? Was it pretty good, or?
It's approximately 7/8 of the entire population.
Well, this is not 8/8, right?
I've had plenty of those where I put a submission and I like accidentally shuffled something, or just something was wrong, and then I go and it's like I get like the physical worst possible thing, like I get a negative result. That's what ended up making me, when we were working on the Human Protein Atlas one, I ended up quitting that after I let a model run for like essentially like 18 hours. And then I went to submit and I was like, oh, it's going to be so much better than that other one I did that only took 2 hours. And then I submitted it and it's like 0.004 or something like that. It's just like random guessing. And it's like, okay, I screwed something up, but I'm not going to spend time to figure out what.
Yeah, 18 hours, dang, yeah. How big was that data set?
That was the images that we were looking at a while ago. So I was trying to do the Human Protein Atlas one, the one where we're trying to figure out, is there a ribosome, is there a whatever in the images?
Mm-hmm.
And so before we were looking at the 256 by 256 images, and I was trying it on the 512 by 512. So it just took so much longer just to run through the data.
Wow.
And I obviously did something wrong because it didn't work out.
Mm-hmm.
Did not pay off.
So what you're saying is this could this could not pay off. No, that's, yeah, I get that.
It doesn't pay off if you quit. That's the biggest thing. If you keep going and eventually you figure it off, then you get the payout. It's like what they were talking about in the video, where nothing works up until you make it work, basically.
Man, it's so frustrating sometimes, especially with all these different packages. Like I was reading that in pandas, like a slice actually includes the last, like a 3 to 7 slice will include the boundaries of it too, which is different than Python.
Yeah.
So like all these different things that you have to remember to get anything done, it can be frustrating. You just have to pretend that you're the sort of person that never gets frustrated, otherwise you'll get frustrated. That's what I'm doing. I'm trying to pretend I'm the sort of person that never gets frustrated.
Just totally relaxed. Yeah. Nothing on.
In my case, I used a label encoder, and I got to 0.29, which is, I think it's less than 0.32 that you guys said with a one encoder.
One of the things to keep in mind, though, is that there's going to be variation between runs, and also we were handling some different variables too. We might not have, we might have thrown in additional variables on accident.
I see. But say once I got to this point where I computed something and I'm happy with that, what do I need to do? I click on commit, or how do I save? Or
Commit will save it. Are you trying to go to the point where you're making a submission? Like outputting a file and everything.
To save it so I can play with it later, but then also to see what the steps will be to commit, to send the submission.
Commit, all you have to do is hit the top right, and then it'll save that current version and have that ready for you.
Commit necessarily means that you turn in like your reject or just code.
So committing is basically, it's just like on GitHub or something where it's just, I'm just saving a checkpoint in my current code. And then there's an option later where you can actually hit submit to competition, which is entirely separate. So you're not necessarily submitting to the competition every time you hit commit.
I was just doing that right now. I was like, figuring, how do you submit? It was like, I committed, but it's not like a non-leader.
Yeah.
Yeah, to submit it, you have to make a file, the CVS.
You have to scroll down.
Scroll down and submit it.
I got 6 pieces.
I see. So after I click on commit, it says version 2, and I have a link. I copy that link, and then whenever I want to work on it, just return to that link.
Yeah.
Okay.
in my head out before I can't get home.
Are we doing anything?
No, I don't think so. I think we're pretty much good.
So we like for your case, like which category did you convert to like wanna include?
What's that?
Which categorical like label did you convert?
It was the breed.
Breed?
It was
Breed
the-
one or?
That was the only one that I intentionally did. I don't know if I accidentally changed anything else, but I intentionally changed breed to one hot encoding.
Breed 2.
Breed 1.
Breed,
breed 1.
Yeah.
Breed 1, I'm sorry. Yeah, breed 1 to 1 hot encoding.
Did you compare like a difference between like before changing, after changing?
Oh, I didn't take a snapshot of what the model was coming up with prior to doing today's work.
Yeah, because I'm wondering like like the gain, the performance gain we can get.
It should be possible to just remove all the breed columns and rerun the
Yeah.
right, and this way I'll have a comparison.
Yeah, that's possible.
Yeah, I might try that. Okay, good idea.
All right, see you all next week.
Bye.
Do you have to remove the columns, or you simply just go into the where you do the fitting? I think you have a variable that will have the features that you're trying to do the fitting on.
Yeah,
So-
that's what we did last time. We included a list of the columns to do the fitting on,
Yeah.
but this time around I just submitted the entire data frame, and so
So that's what I'm showing right here is I just use the entire data frame and I drop the stuff that we're not looking at right now, like the text and the pictures and that stuff. So yeah, this is including a whole slew of additional features that we weren't looking at before. So that's probably why we have a discrepancy between our two scores.